Every time you type a message, send a text, or even drop an emoji, your computer is working behind the scenes, translating letters and symbols into patterns of ones and zeros. But how does it actually work? How can computers, which only understand numbers, make sense of words and even emojis? Let's break it down. Computers don't see letters the way we do. Instead, they assign each character a number. This system was standardized years ago as ACSII, American Standard Code for Information Interchange. It's a fancy way of saying that every letter, number, and symbol get a unique number code. So, when you type hi, your computer is actually saying 72, 73, and 33. It looks up these numbers in a chart and display them as letter on your screen. And behind the scenes, even these numbers are stored as binary, just ones and zeros. But there's a problem. ACSI only allows for 256 characters. That's enough for English and a few symbols. But what about accented letters? What about other languages like Chinese, Arabic, or Hindi? What about emojis? ACSI just wasn't enough, so we needed something bigger. Enter Unicode. Unlike ACSI, which only use 8 bits per character, Unicode can use 16, 24, or even 32 bits. This means we can now represent over 4 billion characters, including every human language, mathematics symbols, and even emoji. With Unicode, text messages, websites, and apps can now display any language on Earth. But let's talk about the fun part, emoji. Ever wonder why emojis look different on Android and iPhones? It's because Unicode only assigns numbers to emojis. It doesn't tell companies how to draw them. The face with tears of joy emoji, for example, is Unicode U plus 1F602. That's its official number. But Apple, Google, and Microsoft each design their own version of how it looks. And just like letters, emojis are stored as numbers, which computers then translate into images for us. So, every time you send a message, you're really just sending numbers. Whether it's hello or a face with tears of joy, your device is translating everything into ones and zeros using ACSI, Unicode, and a lot of math. Next time you use an emoji, remember, you're not just sending a picture, you're sending a secret code. But wait, how does a screen display different colors? Enter RGB, red, green, and blue. Every pixel on your screen is made of tiny lights in these three colors. By mixing different intensities of each, we get millions of colors. Each color is represented by three numbers. For example, 255,0,0 means pure red. 0,255,0 is green. And 0,0,255 is blue. But what if we mix them? By adjusting the values, we can create over 16 million colors. So, whether it's text, emojis, or images, your computer is doing some serious math behind the scenes, converting everything into numbers. And now you know how computers see the world. What if I told you that videos aren't actually moving? That they're just a bunch of pictures shown really fast? That's right. Videos are just images, and sound is just numbers. Remember flip books from when you were a kid? If you flip the pages fast enough, your brain sees motion. That's exactly how videos work. Every video you watch is just a series of still images, called frames, shown repeatedly. Movies are typically 24 frames per second, while most videos are around 30 or even 60 frames per second. Since each frame is an image, and we already know computers store images using pixel and RGB colors, a video is just thousands, sometimes millions, of images strung together. But why are videos so huge? Because a single high quality image can take up megabyte of space. Multiply that by 30 images per second, and now you need gigabytes just to store a short video. That's why videos use compression like MP4 or H.2064 to reduce file size by removing tiny details you won't notice. Now that we understand video, let's talk about something just as important: sound. Sound is different from video because it's not an image, it's a wave. So, how does a computer store something like this? Sound is made of vibrations, which we measure as waves. A computer can't store smooth waves, so it breaks them into tiny points, like taking thousands of snapshots per second. This process is called sampling. A standard audio file samples sound 44,100 times per second. That means for every second of music, there are over 44,000 tiny numbers representing different points on the sound wave. Each of these numbers represent a frequency or pitch of the sound. Higher frequencies means higher pitch sounds, while lower frequencies mean deeper sounds. But pitch isn't the only thing that matters. We also need to store volume, how loud or soft a sound is, and duration, or how long it lasts. So, just like RGB colors represent an image using three numbers, we can represent sound using three key values: pitch, volume, and duration. And if we want different instruments, we just add more data, like a fourth number to tell the computer if it's a piano, a guitar, or even a synthesizer. That's how computers store music files like MP3s or even digital sheet music. So now, imagine combining thousands of images per second with thousands of sound samples per second. That's how we get movies, YouTube videos, and video games. The video part is just images, the audio part is just numbers. Put them together and you have a full multimedia experience. Every time you watch a video online, your device is encoding millions of images and sound samples in real time. And that's how computers bring videos to life. Thanks for watching. If you enjoyed this breakdown, don't forget to like and subscribe for more tech deep dives.